Hi everyone, this is Dr. Gwen Schlichter. This is a mini lecture that's part of a series of mini lectures on the marine environment, physical and chemical features of the ocean. Today I'm going to focus on talking about properties of water because this is a really important aspect of marine biology, right? If we're talking about the ocean, we can't get away with not talking about properties of water because this plays a big role in how the ocean functions. One of the first things that you should be thinking about when you think about properties of water is, what does a water molecule even look like? And could you actually draw a molecule of water? I hope most of you can. No biggie if you can't. But it looks something like this, okay? We have 2 atoms of hydrogen and 1 atom of oxygen chemically bonded together. This is a very special type of chemical bond, and we'll talk about that. Water is super unique. It's the most unique and important molecule out there. But what are some of those unique properties of water? I'm going to tell you about those different unique properties and why they're so important in our ocean. These molecules are held together by a special type of bond that's associated with the fact that water molecules have a slight positive and negative electrical charge. The positive part is part of the hydrogen, and you can see that in the picture here. And the negative is associated with the oxygen atom. Okay, so that's great and all. You're like, yeah, whatever, I need chemistry. This creates something called a hydrogen bond, okay? And this is shown here with that positive and negative attraction. So because of their slight electrical charges, it means that water molecules just love each other. They just want to be together. They're electrically attracted to one another. The negative charge is going to be attracted to the positive charge, and this is known as hydrogen bonding. And it means that it's cohesive at most temperatures, and that's why we have liquid water. This form, this structure that brings those molecules together and keeps it in a mass, right? In a string of water, okay? And this is super important for a lot of organisms, not just for our ocean. And so it looks something like this, and you can see that there's just a lot of love going around here in our collection of water molecules. And it looks like something like this when we actually think of a whole bunch of liquid water, right? And as you heat it up, though, these water molecules will turn into vapor, and this is what it shows you here. But in general, when it's in liquid form, they're very cohesive and they create a mass. Solid water floats. And that may not seem like a really big deal, but if you start thinking of things in their solid form, not very many things, in fact, I think it's one of the only things where the solid is actually lighter than the liquid. So solid water floats, solids are lighter than the liquid, and it's the only substance on Earth that naturally exists in 3 states. Okay, we see it in all 3 states on Earth. And so ice is super important for the marine environment. That's why I have vanilla ice here. So which has a higher density? What do you think? Fresh water or seawater? Here's a picture. Water molecules at lower temperatures are closer to one another. You probably already know that. So when you're at lower temps, you can see how tight it is, and at warm water here is really much more spacious. So when molecules are closer together, the substance is said to have a greater density. So what does that mean for the makeup of the ocean? The density and the temperature? Well, here you can see that higher densities are heavier. So cold water sinks underneath the warmer water. And so this creates what we call a thermocline, where you end up with these colder, deep water oceans. So temperature profile of the ocean is shown right here. And you can see as it's warm, that warm water drops, and then we have this sort of area here where we have cold water sinking underneath warmer water. And this shows you it in another diagram. You can see we have that cold water sinking and mixing, and then that colder water is warmed up, and that will move upwards. Okay, and then there's always warm water up here because there's heat input by the sun. So upwelling water typically is colder, and it's rich in nutrients. And so this is where we see an upwelling here, right? This is where we have that deeper cold water in certain locations will be then pushed back up here to the surface, and that warmer surface, which moves offshore, is pushed away by the winds, okay? And we call that an upwelling. because it rises beneath the surface to replace the water that was pushed away. Because remember that we have that sinking going on, and so then we have that constant movement of water as it sinks and then is brought back up. And that's what we call an upwelling. And it's extremely nutrient rich because it's bringing nutrients from the bottoms of the ocean. So the surface waters are very high in biological activity, and often they're extremely important areas for fishing. And what happens is that when you get an area, because of this constant movement that we're talking about and upwellings, you get what we call the global conveyor belt. Okay, you get this thermohaline circulation that has to do with that deep water formation, the surface current, and we have deep currents that are moving. And this is water moving as it's cold and then warmed up. And it's going to constantly be moving through a sort of conveyor belt across the globe. And that's why I want you to make sure to watch the videos that specifically talk about the global conveyor belt, because it's really important for how different types of richness in the ocean, so productivity, is moved around in the ocean. Colder water holds more oxygen. That's another thing that makes the ocean super different, right? Because it holds more oxygen, so it's really important for organisms that are living on the ocean floor. And colder water is denser than warmer water. But remember that when it freezes, and vanilla ice will remind you, ice, ice baby, when it freezes, then it's a whole other story, and we'll talk about that in a minute. Ice is less dense than liquid water, and that has to do with the fact that when it crystallizes, then air is trapped in it between the bonds. So it creates this matrix, and this matrix means that there's a lot of air in there, and so it floats. And this is really, really important for organisms, because if ice froze around things when it got cold, it would drag organisms to the bottom of the ocean. And the fact that ice floats on the top means that it's also insulating. And so what would happen if ice all stayed at the bottom? Well, trouble would happen. If ice did not float, then a body of water would freeze from the bottom up, and eventually the whole body of water would freeze. Since it floats, the floating ice creates a barrier between the air temperature and the water below the ice, keeping it from freezing all the way through. So floating is super important, and it insulates that water, and it prevents it from having an ocean of ice, right? There's a lot of latent heat, so high latent heat of melting is something that water also has that's very unique. It means that ice melts at a relatively high temperature, and it absorbs a great deal of heat as it melts. And here's a picture here to sort of demonstrate that for you. So you can see that the amount of heat required for a substance to evaporate is called the latent heat of evaporation. Okay, so it takes a lot of heat to get vapor, and a great deal of heat is required for that evaporation to occur, and you can see that here. And we know that when we're trying to boil water for coffee and tea. And water has the highest heat of evaporation of any naturally occurring substance. Why are the seasonal temperature fluctuations milder in Seattle than on the east side of Washington? So this figure shows that land heats up faster and to a higher temperature than water, okay? Water heats up less quickly and to a lower temperature than land. What this means is that it has high heat capacity, as I mentioned before. Water absorbs a great deal of heat before the temperature rises. When you are near the coast, you'll see that the ranges of temperature from hot to cold are very mild relative to areas where water is not there. And what's interesting about water is it has one of the highest heat capacities of any naturally occurring substance. And that's important for marine organisms as well, because they're not subject to wide temperature ranges like they would be on land. Now, of course, small bodies of water are the exception to that, because they can warm up very quickly because they're just a smaller volume of water. Water is the universal solvent. So what does that mean? It means like just about everything dissolves in water. And a solute is a term we use for any substance dissolved in water. And what mainly is able to be dissolved in water is sodium and chloride, which is what makes salt, right? And so that's why the ocean is very salty. And here's a picture that shows you the sodium ion and the chloride ion in water molecules. And you can see that water really likes salt. It's attracted to salt because remember, it's very positive. Sodium's very positive, and chloride is very negative. And this shows you the composition of salinity in the water. We measure that in parts per million. And you can see here that we have a very, very high percentage of sodium and chloride. And these are the highest things. There are other things in the ocean, but just not as high a number. And these other trace minerals are really important for marine organisms. Another unique property of water is that water is transparent. And that seems like kind of like a duh. Of course, Dr. Gwen, of course it is transparent. But what does that really mean for the marine organisms? What that means is that sunlight can get through water, right? And if sunlight can get through water, then photosynthetic organisms can live underwater. And where the light penetrates the ocean means that those are where we're going to find photosynthetic organisms. But that level of penetration varies greatly. So it can depend on a lot of other solutes that are in the water. Okay, so it's not universal across the board. There are photosynthetic organisms at a certain depth because it can vary from place to place. So are all the conditions the same at all depths? Well, I think that you pretty much know that that's not the case. But these are the things, the properties of water or properties of the ocean we want to think about: salinity, temperature, light, pressure, and oxygen. And we've talked about all of them except for, of course, pressure. The conditions are not the same at all depths. Okay, so they can vary greatly. Oxygen content, temperature, salinity, all super different from one depth to another. Pressure also increases with depth. And so you want to think of pressure as water at the bottom has the weight of water pushing it down, right? Because it is above it. And so here's a little image here, and this is why they wear and have such complex machinery when they go really, really deep. It has to be, it's measured in atmospheres, and you want to think about how that pressure increases. It increases pretty dramatically so that you have to have some sort of special kind of gear to go very deep. Otherwise, it would crush you. And what's really cool about the deep water is that because it has this crazy high pressure, there are organisms that are adapted to it, and they are crazy looking. You can see here we have, a blobfish, for example. This is a type of octopus. This is a vampire squid. Organisms have to take unusual shapes to deal with that high amount of pressure. And because of that, they have these amazing adaptations, and they're really, really, really cool to look at. All right, so that is a lot about how cool water is. I hope you enjoyed learning about it, and I will have other mini lectures that are associated with the marine environment so you can learn more things, so stay tuned. Thank you so much for watching.